This is so cool. I'm loving it. Right now my favorite load is a 100 ohm resistor and a 2.2 microhenry inductor in series right there. Right there. That's 100 ohm and that's a 2.2 microhenry, and they're in series in that socket. That's the load socket. Here's where the zener goes. I've put a socket in there so I can try different zeners, but right now, as you can see, there's no zener there. And I got the oscilloscope probes hooked up to the correct locations, and this is the on-off switch right there. And there's some other load things that I've been playing with. The capacitor in the zener hole is very interesting. Very interesting behavior with that capacitor in the zener hole. And maybe I can show that in this video. The annoying hum that you're hearing in the background is the discharge machine, so just don't pay it any attention. And don't pay any attention to that either. So at any rate, this is the Altoids. It's the world's first pocket-sized, completely self-contained free energy demonstration device. It produces a negative power product, negative energy integral, and all I have to do is turn it on, like this. And there you have it. The top trace, of course, is the current through the shunt, or CVR. The zero baseline is, sorry about the light. The zero baseline's right there, running right across there. That radical marker right there. You can see there's a strong negative going current pulse. And this trace down here is the battery voltage. And the battery voltage is being shown at 20 volts per division. There's a little negative going portion there, but a good positive hump. And that positive hump and that little negative going portion, that's going to be multiplied by this big chunk there. And then the positive going portion of the current waveform gets multiplied by this portion here where the battery voltage is actually very low. Let me make sure that that's actually on its baseline. It's down a little bit, so it's not as low as it looked at first. Should be right there. Okay, that's still pretty low on the battery voltage, 7 volts or so. So this trace is going to be a strong negative. Let's make sure that one's in the right place too then. Sorry, we're triggering on that one. Yeah, that one has not moved. Okay. So there's our zero current baseline. Anything below that indicates so-called reversed current, multiplied by this peak hump here. So this trace is going to give us a good, strong, negative mean power product and a negative going integral. So there you have it. If a mean negative power product is proof of overunity performance, then what you're looking at is an overunity device. Okay, but now what I've noticed is I can't get this circuit here to run with a 3.3 volt zener in the zener department. I've got that one, let's see, this one right here is a 3.3 volt zener. And when I put it in, it just acts like a short and causes the circuit to stop working. See if I can, oops, oh no, I dropped it on the floor. Ah, there it is. Maybe I should use a pair of tweezers to manipulate that. Do I have some tweezers over here somewhere? I had some tweezers. Yeah, there's some tweezers there. Magnetized tweezers. So at any rate, if I put this little zener in there, what happens is it actually kills the oscillations. And so here you're just seeing the straight battery voltage, and here you're right at the zero baseline on the current. So the circuit's just dead with that zener in there. It's not doing anything. Okay. So that's a 3.3 volt zener. Okay. And then this is a 5.1 volt zener here. I think I can put that in with my fingers. There. So with the 5.1 volt zener in there, what we get is a decrease in the frequency of the oscillation. But we still get, right, so the frequency's gone down some. Or has it gone? Yeah, it's gone down, right? So there's 3 full cycles, and without the zener in there, well, today we hardly seem to have any effect with this load. But with an LED load in there, the presence of the 5.1 volt zener causes the frequency to drop and the waveform to change quite a bit. But with this my favorite load right now, even the 5.1 volt zener doesn't make a lot of difference. So it's acting as though it were still an open circuit in there. Now if I simply take a piece of wire, if I simply take a piece of wire and short across where the zener goes, like this, you see again that it just kills the circuit with zero current and battery voltage shown. Okay. Alright. Now here's the interesting thing. This is a 0.01 microfarad capacitor. Alright. So remember where the zero current baseline is. A little bit more light on the screen there. Zero current baseline is right there, and it's marked by that little marker right there. Okay. So now I'm going to take the capacitor and just put it in the same place where the zener normally goes. Okay. Just like that. Okay. Now I just touched that capacitor to there, and now I've removed it again. Okay. It's not in there anymore. But look where the current is. Remember where our baseline is? Right there. So the current has gone up. This is being shown at 0.05 volts per. So that's 50 millivolts of current. That's just below the 50 millivolt line. It's 40 millivolts of current being shown. Or 40 millivolts, yeah, and it's a 1 ohm resistor. So that's 40 milliamps of current right there being shown. And the capacitor's not in there. I just touched it briefly and took it out. So now I'm going to switch the circuit off and then turn it back on. So off, on. Alright, let's do that again. Capacitor, zener, I'm going to put it in one point right there, and then I'm going to rock it over and touch it to make the connection. Okay. There's the connection. Now I've broken the connection. Capacitor's not in there anymore. There's our 40 millivolts, which translates to 40 milliamps of current. Now I'm switching off. Now I'm switching back on. And there you go. Alright, sports fans, explain that. Thank you for watching.